Welcome to On Chemistry. In this video, we are going to see what is anti-CRAM'S rule. It is an important concept in organic chemistry, particularly in asymmetric synthesis or distereoselective synthesis. We will see basics, tricks, and problems. Stay tuned. What is inside this video? First, we are going to see what is anti-CRAM'S rule and basics behind the CRAM'S rule, which includes condition for CRAM'S rule, tricks behind the CRAM'S rule, and common mistakes everybody will do while solving the CRAM'S rule problem. Then examples. The examples are all from various exams. We are going to see fully solve 9 examples for your complete understanding. At first, we will see what is anti-CRAM'S rule and basics involved in the anti-CRAM'S rule. Why the anti-CRAM'S rule required? Let us have the ideal condition. You have carbonyl, alpha position, you don't have any groups, just hydrogen. You are reacting with methyl mercury. The methyl can add above the plane or below the plane. Here I shown dotted and wedged structure. So possibility is 50-50. The interesting case is B. Suppose you have alpha chiral center which has coordinating amine. If you attack with methyl, that is methyl mercury, you have one major and minor, not the 50-50 enantiomer. The reason is diastereoselectivity. This is due to anti-CRAM'S rule. So basics behind the anti-CRAM'S rule is alpha steric carbon create the selectivity. So technically, what is anti-CRAM'S rule? Suppose you have carbonyl which is prochiral center which is going to be chiral. In alpha carbon you have chiral center amine, methyl and ethyl. So methyl due to the steric effect attack from specific position. That is what defined by anti-CRAM'S rule. That's why you have major and minor. It is a simple nucleophilic addition with selectivity. You can say this is asymmetric synthesis or diastereoselective synthesis. Here what will decide the major product mean the chelating group. Amine decides the major product. Here before getting into the problems, you should know the basics. The labeling of the molecules. The labeling will be Z, L, M, S. Z is the chelating group. We will see that in shortly. And L is large group. M is medium group. S is small group. Here Mn plus mostly the metal cation. So you should know this terminology before getting into the basics. As we seen, Z group is the chelating group. It can be a medium group or it can be a large group. Here I shown example 1. PHO is the coordinating group, that is oxygen. The Z group is same, L group is same, coordinating group as well as large group same. In example 2, Z group is the medium group, L group is the ethyl group. So careful with the nomenclature. First you label large, small and medium. Z is straightforward because of lone pair. So careful with the Z group identification. So anti-CRAM'S rule, how it will happen? Basically a chelation of metal. In alpha chiral carbon, you have coordinating group that is sulfur, nitrogen or oxygen which has lone pair. It can act as a ligand. Metal is there mean it can coordinate, form cyclic coordination complex that is called chelation. So coordination in the cyclic form create the chelation. The chelation activate the carbonyl and increase the kinetics of the reaction. So chelation provide two factors. One is kinetics, another is selectivity. So let us get into the detail. The anti-CRAM'S rule contain Z group which is coordinating oxygen, nitrogen and sulfur, sometimes phosphine oxide. It can be a derivative of oxygen, which is OH, OR, or OMe, or amine, or diamine, or amide. The sulfur also can coordinate sulfur and alkyl sulfur. The chelating metals are magnesium, zinc, copper, titanium, cerium, magnesium, manganese, and lithium. So basic reaction is where the Z is, where the carbonyl is, you create the final product. If the Z group and CO syn mean, the nucleophile attacks small side. If it is anti-mean, nucleophile attack the medium side. Here there is some exception. Non-chelating groups are fluorine, chlorine, bromine, iodine. Non-chelating metals are sodium and potassium. So you should know the rule as well as exception. How you memorize this? Basically, you create the acronym. It is easy. First, you should find relationship between. Then you find the final product. Here, syn means small side attack. Both are start with yes. It is very easy. Syn means small side attack. Anti mean medium. So you derive from syn, which is opposite mean anti. So syn means small side attack. Before getting into the detail, you should know Cram's rule versus ANTI-CRAM's rule. This is to avoid the confusion. Better you memorize any one and write the reverse to find others. Cram's rule basically dictated by the large group. ANTI-CRAM's rule dictated by the Z group. In Cram's rule, large group and CO syn mean medium side attack. Anti means small side attack. In ANTI-CRAM's rule, Z group decides. Z group and CO syn mean small side attack. Anti mean medium side attack. So Cram's rule, large group is important. ANTI-CRAM's rule, Z group is important. Let us see the most confusing factor to find the anti or syn position. Here is shown the various possibility. In the first molecule, amine and carbonyl anti to each other. If you rotate also, you will have the same, but it may look like syn. But syn group is only methyl, not amine. So careful with rotation. Always follow the solid line. Then second one, here you have syn relationship. Carbonyl and amine is straightforward. It is easy. And third one is anti because carbonyl and position 180 degree to each other. So it is anti. Fourth one is like simple one. Amine and carbonyl simply on syn position. And fifth one also straightforward. Amine and carbonyl can be anti. You might observe carbonyl can be above or below, but you should find the relationship between Z group and carbonyl. Then Sagas projection, carbonyl and amine anti to each other, straightforward. Then the seventh one, you have amine and carbonyl relationship cannot be defined. Why? Because carbonyl written as combined, no clarity on that. So there can be many possibilities. Anti position, you should master that. Here is given guidance to find the anti position. Suppose you given a molecule. The molecule is with dot, wedge and solid line. If you remove dot and wedge, relationship will be clear. Here methyl group is anti, so you can derive amine might be syn to each other. So you find the one and guess the second. So basic step is remove the hydrogen, write the solid line, not dotted or wedge line. Clearly you can define anti or syn. Based on that you guess other. Then the very important basics, position of alpha chiral carbon. Here chiral carbon is crucial because it creates the selectivity. Here I given two examples 1 and 2. One chiral carbon is nearby which create the diastereo selectivity due to the chelation possibility and the final product with high selectivity. On the contrary, chiral group is far away from the carbonyl, that is Z is away from the carbonyl. You don't have any selectivity, no anti-Crams rule. So careful with the position of alpha carbon. Alpha carbon dictate the final product. Then the next basics. Do you really need anti-Crams rule in some condition? First example I shown. Alpha center is not chiral carbon. So finding the final product, regio selectivity don't matter because anyway you end up with same product. The similar situation, attacking species and hydrogen, the product is not chiral mean guessing the final product also not useful whether it can be above or below since both are hydrogen there is no selectivity no grams rule. Why I given this? Because you should know the concept to the deep level to solve the problem and create your own synthetic pathway. Then the very basic one, to avoid the confusion, always draw the all atoms. Here the example is given. Methyl and amine is in alpha chiral carbon, but hydrogen is hidden and stereochemistry also hidden. So if you redraw always, you avoid the confusion. You can eliminate the errors. The final basic is how you find the product, or you can say how you apply the anti-Grams rule. First step will be we should find whether anti-Grams rule or Grams rule applied. Then you should label large, medium, small and Z group. Then find the relationship between CHO and Z group. If the relation between Z and CO is in mean small side attack, if it is anti mean medium side attack. And you should not forget, you should draw with stereochemistry where the attack happened, which is solid line, which is dotted line, and don't forget the exception, sodium and potassium and halogen don't chelate. Then we are going into the very important session, solved examples. Here I given 9 solved example. It gives you different perspective and complete understanding. The problems are best way to learn. Whenever you study the concept, always solve the problems. Let us see the first example. Here you have ketone, one side phenyl, another side chiral carbon with ethyl, hydrogen and OH. OH is above the plane, hydrogen is below the plane. You are using zinc borohydride. You should find what will be the final product. Here you have alpha chiral carbon and carbonyl. Attacking species is nucleophile. Here OH is coordinating. Zinc also chelate mean anti-Cram's rule applied. First we will label large, small, medium and Z group. Z group is straightforward which is OH. Large group is ethyl. Small group is hydrogen. Medium group is OH. Relationship between CO and OH is anti. So let us apply the table. If it is anti mean medium side attack. Here medium group is OH which is above the plane. Nucleophile is hydrogen which will also attack above the plane. So the attack happen. OH come below, hydrogen come above. That is the final product. The concept you have to learn here is always master the relationship between Carbonyl and Z group. Then the next example. Here you have ketone. One side you have phenyl. Another side you have chiral carbon. OH, hydrogen, ethyl is there. OH is above the plane. Hydrogen below the plane. You are using sodium borohydride at one reaction. Another reaction you are using sodium borohydride with cerium chloride. You should find what the difference the reagents can make. Here two different conditions, two different products. One is anti-grams, another is grams. Grams mean only with sodium borohydride. Here large group is ethyl which is syn to carbonyl. So attack will be on medium side. Here medium is OH group. So the attack will happen on medium side. So hydrogen on above the plane. because OH is above the plane. Final product hydrogen above, OH below. On the contrary, if you use sodium borohydride with cerium chloride, attack will happen based on Z group. Z group and OH is anti, so medium side attack. Here medium group is OH, so attack also happen with OH side. OH above the plane, hydrogen above the plane, OH below the plane. Both products are same, just a different concept. The concept you have to learn here is in Crams rule, large group decide the final product. In anti-Crams rule, Z group decides the final product. Then the next example. Here you have carbonyl. It is a ketone. One side phenyl, another side you have phenoxide, methyl. Methyl above the plane. You are using the butyl lithium. You should find what will be the final product. Here you have carbonyl. Coordinating group PHO is there, which is derivative ether, which can coordinate. Lithium is the metal. So chances of anti-CRAM'S rule. So first let us label Z group, L group, S group and M group. M group is phenyl, S group is methyl, large group is phenoxide, which is also Z group. Here Z group and large group, which is phenoxide, both are same, and small group is hydrogen, medium group is methyl. The relationship between oxide and carbonyl is syn. So according to the table, Z group and carbonyl, syn means small side attack. Here small is hydrogen, which is on back side. So attack happen on back side. Hydrogen below, so Bu also below. So OH come above. So the final product OH above, butyl group below the plane. The concept you have to learn here is in butyl lithium, nucleophile and coordinating species from the same compound. Then the next example, here you have carbonyl, which is ketone. One side you have phenyl, another side you have chiral carbon, which is amine, ethyl and hydrogen. Ethyl above the plane, hydrogen below the plane. You are heating it up. Dimethyl mercury you are using. You should find what will be the final product. Here you have carbonyl and you have coordinating amine. The metal is mercury, it can coordinate, so chelation is possible. So anti-CRAM'S rule. First we will label Z group, large group, medium and small group. Here large group is ethyl, small group is hydrogen, medium and Z group is amine. The relationship between carbonyl and amine is syn to each other. According to the table, Z group and carbonyl syn to each other mean small side attack. Here small group is hydrogen, so attack happen below the plane. So methyl attack below, OH come above. The concept you have to learn here is Z group need not to be the large group. Sometime it can be a medium group. It decides the final product. Then the next example. Here you have carbonyl. It is a ketone. One side you have phenyl. Another side you have O-methyl group, hydrogen and methyl. It is a chiral carbon. Hydrogen below the plane, methyl above the plane, O-methyl on line. You are using sodium borohydride. You should find what will be the final product. This problem is given to create the exclusion in anti-CRAM'S rule. Here you have O-methyl group, carbonyl, sodium is there. You should know that sodium cannot coordinate with O-methyl. So Z group metal don't coordinate, mean Crams rule, not the anti-Crams rule. So you should apply anti-Crams rule table. First we will label large, medium and small group. Here large group is O-methyl, small group is hydrogen, medium is methyl. Here relationship between carbonyl and O-methyl is syn. So according to the table, syn mean medium side attack. Here medium group is methyl. So hydrogen attack from methyl side. Methyl above the plane. Hydrogen also above the plane. So OH come below, hydrogen above. You have final product. The concept you outline here is sodium don't coordinate with carbonyl as well as Z group. So Crams rule applied, not the anti-Crams rule. Then the next problem. Here you have carbonyl. One side you have alkene. Another side you have chiral group. The chiral group is with hydrogen, methyl and phosphine oxide. Hydrogen above the plane, methyl below the plane. You are using sodium borohydride, ceric chloride. You should find what will be the final product. Here you have carbonyl and phosphine oxide. Phosphine oxide can coordinate because you are using cerium. Cerium can involve in the coordination. So chelation is possible. So chelation means anti-Crams rule. For that we should label the molecule. Let us label large, medium, small and Z group. Large group is phosphine, medium group is methyl, hydrogen is small. Z group is obviously the phosphine. The relationship between Z and carbonyl is syn. So if we use the table, the Z group and carbonyl, syn mean nucleophile attack on small side. Here small group is hydrogen which is above the plane. So attack happen above the plane. So OH go below, hydrogen above the plane. The concept you outlined here this problem is given whether you are confusing with Michael addition or Gram's rule. Here cerium is there, it activates the carbonyl. Here 1,2 addition, not the 1,4 addition. So Michael addition not applied here. Then the next example. Here you have aldehyde which is connected with chiral carbon. The chiral carbon contains O-methyl and hydrogen. Methyl is above the plane, O-methyl on the plane, hydrogen below the plane. You are using zinc borohydride. You should find what will be the final product. To identify the product, write the reactant with hydrogen and with stereochemistry. Here you have carbonyl, alpha position you have O-methyl, oxygen can coordinate, zinc is metal, so chelation is possible. So anti-Crams rule applied. Let us assign large, medium and small group and Z group. Here large group and Z group is same, O-methyl group, medium is methyl group, small is hydrogen group. The Z group and carbonyl syn to each other, so attack will be happen on small side. Small side is hydrogen which is below the plane, so the attack happen below the plane. So hydrogen attack from below, OH come above. That is your final product. The concept you have to learn here is always write the starting material with proper geometry. Then the next example. Here you have aldehyde. It attached with long chain. In the penultimate position, you have amine hydrogen which is carbon with chiral nature. Amine above the plane, hydrogen below the plane. You are heating it up. Dimethyl mercury you are using. You should find what will be the final product. Here you have aldehyde coordinating amine group, but the problem is it is very much away from the carbonyl. So effect of amine is not possible. Chelation is impossible because of larger ring size. So applying anti-Crams rule will be meaningless because chiral center is very much away from the carbonyl. No chelation, no anti-Crams rule. So there is no selectivity. The product can be racemic. You will have a mixture of products. The concept you outlined here is chiral center should be on alpha position. If it is very much away from the alpha position, mean you don't have any selectivity. Always you will get mixture of products. The concept you outlined here is alpha position should be chiral to get the anti-Crams rule. Then the next example. Here you have ketone. One side you have phenyl, another side you have chiral carbon, hydrogen above the plane, S-methyl group, thioether below the plane, ethyl on the plane. you are using zinc borohydride. You should find what will be the final product. Here you have carbonyl, alpha position you have chiral carbon with sulfur. Sulfur has lone pair, it can coordinate. You are using zinc, it also helps for chelation. So anti-CRAM'S rule is possible. Let us assign large, medium and small group. Here Z group is sulfur because it has coordination. Large group will be ethyl, medium group will be S-methyl, hydrogen will be smaller one. Z group and CO in anti-relationship because they are anti to each other. So according to the table, Z group and CO anti mean medium side attack. Here medium group is S-methyl which is below the plane. So nucleophile attack below the plane. Hydrogen attack below the plane. OH come above. That is your final product. The concept you have to learn here is sulfur also can coordinate, which involve ANTI-CRAM'S rule. Let us summarize what we learned. In ANTI-CRAM'S rule, to find the product, you should use the table, which is find the relationship between Z group and CO. If Z group and CO syn to each other mean small side attack. If Z group and CO anti mean medium side attack. You can memorize this easily because syn means small. Yes, the word will be same. So you can memorize it easily. Here Z group can be the atoms with lone pair, oxygen, amine as well as sulfur. All can be with substitution, but main atom will be oxygen, nitrogen and sulfur. Phosphine oxide also can coordinate. Give the anti-CRAM'S rule. The chelating agents, that is metal, can be magnesium, zinc, copper, titanium, cerium, magnesium, manganese and lithium. The non-chelating groups are important, which creates the exception in the anti-CRAM'S rule. Non-chelating groups are fluorine, chlorine and bromine and iodine, that is halogens. Non-chelating metal ions are sodium and potassium. These are all you should memorize to master the anti-CRAM'S rule.